everything's decreased, but Alzheimer's has grown. Stopping it, preventing it, postponing its development in our brains long enough that we at least die of something else with our memories is a real goal we can achieve. Your brain fits inside this thing, your skull. Specifically this part back here called the brain case or neurocranium. It's a bone fortress protecting an inner sanctuary called the cranial cavity. Your brain sits right here, except it doesn't really sit so much as it swims. You see, the brain is incredibly fragile and soft and gooey. Model or toy brains tend to be made out of rigid plastic, and actual specimens used in dissection tend to be rubbery because they've been affected by chemicals like formaldehyde. But real, raw, fresh brains, right out of someone's brain case, are soft, like soft tofu. Holding one like this for too long will leave a lasting hand-shaped depression. For that reason, the brain has to float so it doesn't crush itself under its own weight. But it doesn't float in water. Instead, it floats in a special liquid your body makes called cerebrospinal fluid. Now, this isn't a whole brain. This is just the cerebrum, the largest part of the brain. It plays a key role in language, thought, abstract thinking, awareness, consciousness. It thinks it's a pretty big deal. Literally, it's the part of you that does thinking. Anyway, the outside of the cerebrum is called the cortex. Cortex means bark, like tree bark, or a rind, or a husk. If I tear off one of the temporal lobes, we can take a closer look at this rind. It's painted in maroon here. You can see its extent. It's only about 2 to 4 millimeters thick. It's often called gray matter because it appears pinkish yellowish gray in a real brain. Beneath it is the white matter. White because although gray matter contains a lot of cell bodies, the white matter contains mainly axons that are myelinated that send messages from gray matter to gray matter locations. Myelin is a whitish material that insulates electric messages, allowing them to move faster. And fast, they do move. Signals travel through axons at up to 432 kilometers per hour. That's 275 miles per hour. About the top speed of the fastest production car in the world. You could say this car literally travels at the speed of thought. But that's slow compared to the speed of electricity through a conductor, which is closer to 50 to 99% the speed of light. Anyway, the brain is very wrinkly, and that's because a wrinkled shape allows more cerebral cortex to fit into a smaller container. If we could take this entire rind, all of your cerebral cortex, and flatten it out, it would be, well, about like this. It would be about 2 to 4 millimeters thick and have an area equivalent to a square 50 centimeters by 50 centimeters, about 20 by 20 inches. Obviously, you can't fit this shape into this shape unless you crumple it up. And now we're getting somewhere. When we crumple the brain up, we get folds. The folds are called gyri, singular gyrus, and the crevices are called sulci, singular sulcus. About 2/3 of your cerebral cortex is buried deep within sulci out of view. As for memories, well, every time you learn something new or memorize something new, your brain doesn't gain another wrinkle or anything like that. Instead, memories appear to be more about connections, relationships, and patterns formed by connected neurons. When neurons fire together again and again, rehearse, their connections and bonds become stronger. They become more likely to fire together again, to be recalled. Roughly, that might be how memory works, and it's a helpful way to think about some interesting phenomena, like the fact that it's quite difficult to list off the name of every book you've ever read. That's like really difficult. But if someone were to just name book subtitles, you could effortlessly tell them whether or not you'd read the book. Hearing the